Okay, now I'm audible. Yes, good morning everyone, online students. Yes, this is also a live session on YouTube. So good morning everyone, those who are watching online. So in first part of this session, we will try to address some queries. Online students, if you have query regarding the yesterday's session, if you have read first and second chapter of NCERT, 11th standard NCERT, you must be having some doubts. ठीक है. So Big Bang theory is, we cannot rigidly categorize it as a monistic or a dualistic concept, because in monistic concept it was like there was earlier one celestial body. Big Bang theory says that there was a tiny ball, the concept of singularity. ठीक है, so we cannot say that it is a celestial body. Okay, so it is altogether a different concept. Yes, good morning Dipankar. Other questions? हाँ. Okay, we are going to revise that again, all theories. While dictating the theories, I will revise that. हाँ. ठीक है, आज हम फिर से एक बार रिवाइज करेंगे. ठीक है, प्लैनेटेसिमल थ्योरी बाय चैम्बरलिन एंड मॉल्टन. ठीक है, तो हम फिर से एक बार रिवाइज कर लेंगे आज उसको. यस, हाँ. See, explosion happened because that there was actually, it was having infinitely small volume and very high temperature and density. Okay, so the concept is like, at certain point of time, that density and temperature must have been crossed some limit that may have resulted into that blast, or we can say explosion. ठीक है, समझो एक कोई भी अब हम मटेरियल लेते हैं तो एक सर्टेन लेवल पर उसको हीट करते हैं समझो, एंड देयर आफ्टर इट प्रॉपर्टीज चेंजेस, नो. ठीक है, तो उसी तरीके से हुआ होगा उसमें, राइट. यस, बाकी कोई डाउट नहीं है ऑनलाइन स्टूडेंट्स? यस, दोज हु हैव जॉइंड थ्रू जूम सेशन. ठीक है, okay, let's continue from yesterday and during dictation time I will revise those theories again. Okay, so till yesterday we have covered about how the stars and planets are formed, but now we will try to understand the evolution of the earth. Okay, so evolution of the earth, we'll see the evolution of lithosphere, atmosphere and biosphere. Okay, first of all, lithosphere. In lithosphere, what do you mean by lithosphere? Litho, something related to earth crust, we can say, which is in solid in state. It is in solid state. The uppermost part of the earth surface is called as basically lithosphere. Okay, but there is a difference between lithosphere and earth's crust. Today we are going to learn about interior of the earth in second session, so there we will understand in detail, but try to remember this. Lithosphere is basically the uppermost solid part of the earth's surface. Lithosphere, lith means which is solid in state. ठीक है, earth का surface जो है, so lithosphere. So let's understand how this lithosphere is formed. Okay, so when the earth was getting formed as a planet, we can say, of our solar system, what happened is there was basically particles of having different densities. They were having different densities. Now, these particles started resettling inside the earth according to their densities. How they resettled? The particles with higher density, they started going down, and the particles with lower density, they started coming up. This is natural thing that happens with densities. Okay, high density materials, they tend to settle down, आप कोई भी कंटेनर लीजिए और अलग अलग पार्टिकल्स जो है पानी में डालिए, तो लार्जर डेंसिटी वाला जल्दी सेटल हो जाता है नीचे, है ना. In the same manner, these particles started settling down, and the particles with higher density, they started going down. Now, when there was resettling, more and more heat was produced because of friction. Because of friction. Okay. And this friction, and we can say that the heating led to, we can say, even melting of these particles. ठीक है. अब melting की वजह से क्या हो गया, इसका redistribution हो गया. Because of melting of these particles, it started redistributing, it started flowing inside the earth, and it was easy for the material which was less dense to move up. Basically it was in the form of magma. Basically it was in the form of magma, and it was easy to flow up the lower dense material, and the higher dense material, density material, they started settling down inside the or near the center of the earth. And this is how basically the lithosphere was formed. Now the material with less density, which was exposed to the atmosphere, which was comparatively cooler than the interior of the earth, started cooling down and became solid. Okay, became solid. So that's why today's earth crust that we see is in solid state. It is comparatively cooler than interior of the earth. Now the properties of this material that we see today, what are these properties? Properties related to temperature, pressure and density. What happens to these properties as we move from earth's surface to the interior of the earth? Increase or decrease? Increase. All three. Temperature, increase from surface to center of the earth. What about the pressure? Why pressure is increasing? One student is heavier than 5 because of weight. हाँ, क्यों weight? किस चीज का weight? हाँ, बताओ. See, as we move inside the earth, there is the weight of incumbent, या ऊपर जो rocks है ना, उसका weight नीचे वाला face कर रहा है ना. Basically, it is the weight of that particles, rocks, we can say, lying above it. So as we move further and further deep inside the earth, more and more rocks that are there above, they are exerting continuous pressure. That pressure is increasing. Okay. And the general property that we have is, as the pressure increases, temperature increases. अब ये टेम्परेचर ऐसे अंदर जाते हो ज्यादा क्यों है? दिस इज द कॉमन प्रॉपर्टी. एज द प्रेशर इंक्रीजेस, देयर इज इंक्रीज इन टेम्परेचर. बट व्हाट हैपेंस टू डेंसिटी? Density increases. Okay, why? Because I told you what happened when the material was resettling. The higher density material got settled near to the center of the earth. Higher density. Why? Again, gravitational aspect. ठीक है, gravitational force वाला जो चीज है. Remember this. Now, which are the materials that are having high density? Yes, iron, nickel, cobalt, or these heavy metals. They are highly dense and they got settled near the core area or the center of the earth. We are going to talk about composition. There I will explain the density of crust, mantle and core and composition. ठीक है, ये सारी चीजें बात करने वाले. Sir, at what speed is universe expanding? Is it faster than light? No, not at all. ठीक है, at present the universe is expanding at a very slower rate as compared to when this Big Bang event happened. Immediately after that it was expanding at very faster speed. Okay, but at present it can be observed only through telescope, and that too over the period of time. ठीक है, the comparison is done, and thereafter we came to know. Now, how do astronomers or geographers they come to know that universe is expanding? Yes, distance between galaxies. But how they measure distance between galaxies? Yes, how they measure distance between galaxies? The only important source here is observation of light. Okay, the time taken by light to reach on the earth from these distant galaxies, that is the only source. ठीक है, उससे ही हमें समझ में आता है कि डिस्टेंस कितना है इस गैलेक्सी का, कोई भी स्टार का. ठीक है, सो no, that is basically speed of light. That is speed of light. Okay, the time taken we can understand is basically when we have speed. So, and when we have what you can say, when we have speed, when we have time, we get the distance. ठीक है, when we have speed of light we know, when and then we have time, कितने टाइम में कितना टाइम लग रहा है उसको यहाँ तक आने के लिए, then we get the distance. Okay, through this observation, through telescopes, basically we come to find. Now, as the outer part of the earth's surface is exposed to much cooler, we can say, atmosphere, that's why the outer surface started getting cooled. The outer surface started getting cooled. So that's why it is now in solidified state. Okay, and later on various exogenic processes like the work by running water, wind or glaciers, the existing land is basically shaped by these, we can say, exogenic processes. ठीक है, तो yes, new students, ठीक है, so we are learning about evolution of the earth. Do we have any question from the previous session? Have you read first and second chapter of NCERT? तो doubt नहीं है अभी right now. Okay, so we are learning about evolution of the earth, and in that we will learn about evolution of lithosphere, atmosphere and biosphere. So first is lithosphere. Lithosphere is basically the outermost solid part of the earth, and we are trying to understand how this solid part is formed. So when the earth was getting formed, whatever the material or the particles were there, they started resettling according to their densities. More dense materials, they settled near to the center of the earth, and less dense materials, they started moving out in the outer side, we can say. And during this process, due to friction, there was heat generation. And this further helped in easy movement or easier movement of, we can say, more dense material towards the center and less dense towards the surface. So present day properties of these particles of the earth's interior, what properties we are learning? We are learning about their temperature, pressure and densities. So as we move from the earth's surface to the interior, all these properties goes on increasing. Density goes on increasing, then temperature goes on increasing and pressure goes on increasing. So why pressure is increasing? Because of overlying rocks. ठीक है, हम जैसे जैसे अंदर जाते हैं तो ऊपर के रॉक्स का वेट बढ़ते जाता है, दैट इज एक्सर्टिंग प्रेशर. Okay, so as we move from surface to the center of the earth, all three properties are increasing. Remember this. Okay, so this is how the lithosphere is evolved. Further details we will learn in today's session, structure and composition of the interior of the earth. Then about the atmosphere. Now this is important, pay attention here. Okay. When the earth was formed, there was something called as primordial atmosphere. Primordial atmosphere. That means ancient, original atmosphere. And that original atmosphere had a different kind of composition, largely having gases like hydrogen, helium, methane, argon, or we can say those noble gases. So the present day composition that we have, like more nitrogen is present at present in atmosphere, or oxygen is present. Oxygen इतने amount में था ही नहीं पहले, nitrogen इतने amount में था ही नहीं. Okay, so this was the composition, but this particular atmosphere over the period of time changed due to various processes. Now which processes are involved here? First of all, what happened is there were strong solar winds. Okay, when the earth was getting formed, the effect of solar winds was very strong. See, the earth was still getting formed, and that's why the magnetosphere of the earth was still getting formed. And that's why the present day protection that we get from solar winds or these geomagnetic storms was not present at that time. ये हम geomagnetism में पढ़ने वाले हैं, ठीक है, upcoming sessions. Again I am repeating, at present we do not experience that much impact of solar storm on the earth's surface or life on the earth's surface. Why? Because our magnetosphere of the earth protect us from these harmful charged particles. But when the earth was getting formed, in initial time, this magnetosphere was not developed as such, and that's why the solar storms were having impact on earth's atmosphere, and because of that these winds wiped out this primordial atmosphere. It removed the primordial atmosphere. ये सारे gases जो है remove कर दिया उसने. It removed the primordial atmosphere. Then what happened? Slowly, as the lithosphere was getting formed, something called as degassing started. The phenomenon of degassing. Now, what is this degassing? The gases from interior of the earth started coming out to form the new atmosphere. The gases from interior of the earth that started coming out to form the new atmosphere. Now, what kind of gases started coming out? Like, अंदर combustion हो रहा था, CO2 आ गया बाहर. Okay, thereafter nitrogen, thereafter in some amount oxygen also, other gases, noble gases also. So degassing phenomenon was largely as a result of volcanic eruption, extensive volcanic eruption that started happening, and the resettling of the material that was happening inside the earth during formation of lithosphere. Okay, the new gases were now forming the atmosphere. ठीक है. Now slowly the earth's gravitational field started working, holding on to this particular newly formed atmosphere. ठीक है, तो नया जो एटमॉस्फेयर तैयार हुआ उसको पकड़ के रखा अभी, क्योंकि अर्थ का ग्रेविटेशन फील्ड डेवलप हो गया. एंड देयर आफ्टर, ड्यू टू डेवलपमेंट ऑफ magnetosphere around the earth, magnetic field, what happened is the effect of solar winds reduced, and that's why the new atmosphere that we have today is still protected. It is still protected. Understood this? Now the volcanic eruption also contributed to degassing of water vapors. ठीक है, वाटर वेपर फ्रॉम इनसाइड द अर्थ केम अप. आपको लग रहा होगा कोई मतलब दूसरी दुनिया से पानी आया था क्या अर्थ पे? नो, बेसिकली द अमाउंट ऑफ वाटर वेपर that was there inside the earth that came out through volcanic eruption, again the process, extensive volcanic eruption, and that led to formation of now hydrosphere on the earth's surface. Hydrosphere. Now what is hydrosphere? It is water in 3 states on the earth's surface, not 2 states. Alia Bhatt. ठीक है, 3 states on the earth's surface. Which are these? Solid, liquid, gaseous. So as the water is circulating on the earth's surface in these 3 states in a cyclic manner, that form the hydrological cycle or water cycle. Now this led to formation of large water bodies on the earth's surface. These oceans are formed and the water started flowing on the earth's surface in rivers, streams, lakes were formed. As the temperature conditions changed on the earth's surface in the atmosphere, these glaciers and polar ice caps are formed. This is how over the period of time water on the earth's surface changed, and we can say the new forms were taken place. See, hydrosphere played very important role in evolution of biosphere. Why I am explaining this? Next is evolution of biosphere. पानी नहीं है तो लाइफ नहीं हो सकता इवॉल्व वहां पर, राइट? So that's why evolution of hydrosphere. Fine. Now you have understood that present day atmosphere is different from the primordial atmosphere because of these two. And the third activity, ठीक है, I will explain this. Is we can say that once the life started, we can say flourishing on the earth's surface or even in the oceans, there was flooding of oxygen due to photosynthesis. Okay. Originally, oxygen was not even 1% or 2% in the primordial we can say atmosphere. But this oxygen at present, how much percent? 21%, around 21%. ठीक है, तो that much amount of we can say oxygen is there because of photosynthesis. As the life started evolving, especially in oceans, how life is evolved? It evolved in oceans. Okay. वो मत पूछिए कि मतलब पहला कैसे बना और वो सब चीजें, दैट इज नॉट पार्ट ऑफ ज्योग्राफी. साइंस एंड टेक के टीचर को पूछिए बायोलॉजी में, ठीक है? Okay, so we know that as a part of geography, life started evolving in oceans. Thereafter, it shifted to land. Okay, पहले ocean में क्या हुआ? Algae were formed. Thereafter, the marine let's say animals were formed. Thereafter, the amphibians and reptiles, they started coming on the land. Thereafter, the evolution between two separate branches, एक उड़ने लगे और एक चलने लगे, ठीक है? Birds and mammals, ठीक है? तो basically this is how evolution happened. Flooding of oxygen. These 3 steps you remember. One is wiping of the primordial atmosphere by the solar winds, and second is degassing to form the new atmosphere, and the modification of this new atmosphere by the photosynthesis process and adding of oxygen, and we can say taking of CO2. This is how carbon cycle, oxygen cycle, and then hydrological cycle started working on the earth's surface. So if the question is asked tomorrow that explain the evolution of atmosphere, present day atmosphere, you should explain these 3 processes. And now you have understood the evolution of hydrosphere also. Let's try to understand evolution of biosphere. So life started evolving on the earth's surface somewhere we can say 4 billion years ago, and it started evolving in oceans and then shifted to land, we can say. Evolution. See, evolution is not part of our syllabus, biology का part है, again I am repeating. But what happened because of this evolution? The animals, the plants and animals started influencing the physical environment. Okay, animals, that is plants as well as animals, basically it started influencing the physical environment, started making changes. How? Let's say if plants are evolved on the land, what happened because of that? they influence formation of soil. Plants influence formation of soil. The roots that are getting into deeper and deeper, they are resulting into withering of rocks. That is helping in the formation of soil. Okay. Plants are doing photosynthesis. They are taking up CO2 and releasing oxygen. That is further helping other animals to take up the oxygen and release the CO2. This is how they are starting influencing the physical environment. Biosphere is basically, this is how we draw biosphere. कैसे draw करते हैं biosphere को? It is the intersection of three spheres. ठीक है? Atmosphere, lithosphere and hydrosphere. It is biosphere. So it is living at intersection of these three spheres. It is living at the intersection of these three spheres. ठीक है? हाँ. Sir, how does the Earth's magnetic field prevent solar winds? Yes, Anirudh, I will address this question in the next session. That there we are going to learn about the Earth's magnetic field. In detail, we are going to learn about solar winds and how basically Earth's magnetic field protects us from these solar winds. ठीक है? बहुत डिटेल में एक पूरा सेशन हम उसी में पढ़ने वाले हैं. Okay, now you have understood this. ठीक है? So first session actually ends here, and based on that, note down these questions, and at home we have to do practice of writing. Everyone, online students also, you try to write answers to these questions, and you bring or you come up with your answers in the classroom. Class खत्म होने के बाद मुझे वो दिखाइए. This should be your daily practice. ठीक है? हमें प्री पास होने के बाद में या फाउंडेशन बैच कंप्लीट होने के बाद में कोई एक टेस्ट सीरीज ज्वाइन करके पूरा एक साल आंसर राइटिंग प्रैक्टिस नहीं करनी है. दिस शुड नॉट बी अप्रोच. ठीक है? फाउंडेशन बैच में ही आपका राइटिंग प्रैक्टिस होना चाहिए, एटलीस्ट बेसिक वाला. ये डायरेक्ट क्वेश्चंस है ना. राइट एन एक्सप्लेनेटरी नोट ऑन बिग बैंग थियरी. Differentiate between terrestrial planets and Jovian planets. Then explain the evolution of present day lithosphere, atmosphere and biosphere of the Earth. Just now we talked about this. Done? Let's try to solve one or two MCQs also. मुझे just practice के लिए आपका टेस्ट करना अंडरस्टैंडिंग हो रहा है या नहीं है. ठीक है? So although every day we may not solve that, ठीक है? आपको 20-25 साल का मैंने बोला था एक MCQ का लेना है टॉपिक वाइज एनालिसिस के लिए, और उससे वो सॉल्व करने की प्रैक्टिस करनी है. What should be answer to this question? Yes, online students, you also give answers. Neither one nor two. D, Delhi. B, Bombay. D, Delhi. Okay. Online students D लिख सकते हैं. ठीक है, कमेंट में. तो क्यों अलग अलग आंसर्स है? Consider the following statements in which of the all 8 planets of our solar system rotate in west to east direction. Yesterday we talked about this. एक उल्टा घूमता है ना? Incorrect है. Then inner planets do not have primordial atmosphere. I told you yesterday that they are rocky planets. Why? The primordial atmosphere is wiped out because of solar winds. So this is true. इसमें क्या दिक्कत थी? सही है अभी? ठीक है. वीनस. हाँ नहीं, रोटेशन वी आर टॉकिंग. ओके, दैट इज नॉट प्राइमोर्डियल एटमॉस्फेयर, लेटर डेवलप्ड लाइक अर्थ्स एटमॉस्फेयर. ऑल दीज एटमॉस्फेयर हैव एटमॉस्फेयर, sorry, all these planets have atmosphere, but it is not primordial like Jupiter or we can say Saturn. They still have their original atmosphere. ऐसे आपको समझना है. Okay, even Mars is having some atmosphere that is now we can say newly formed atmosphere. Primordial जो है, जैसे हम बोलते हैं जुपिटर का है या फिर सैटर्न का है, अभी भी वैसा ही है, चेंज ही नहीं हुआ. ठीक है. ओके. व्हाट अबाउट दिस वन? ये नया टाइप का फ्रेमिंग है ना. क्या सही है? क्वेश्चन सही है. वो एक मूवी था ना, आई लाइक योर क्वेश्चन बोलता है. गुड क्वेश्चन. तनु वेट्स मनु. हाँ. Yes, answer is A, right? So that means both statements are correct and statement 2 is correct explanation of statement 1. We all agree to this. Do we need to discuss this? Everyone? Yesterday we talked about this. ठीक है. So let's now quickly try to write down the things, important things. ठीक है. And then we'll start with session 2. Origin of the earth. ठीक है. और सॉरी, ओरिजिन ऑफ द अर्थ नहीं, इंटीरियर ऑफ द अर्थ. चलो लेट्स स्टार्ट. लेट्स राइट डाउन. चैप्टर 1, origin of the earth. Write down introduction. Introduction. In this chapter we'll learn about how stars, our solar system and earth were formed. Full stop. We will also understand the evolution of the earth. We will also understand the evolution of the earth and how life started to flourish on the earth. Next subheading, theories explaining origin of the earth. Theories explaining origin of the earth. In that first, let me know the pace of dictation. ठीक है, अगर आपको फास्ट लगता है तो बिल्कुल बताइएगा. ओके, फर्स्ट, गैसियस हाइपोथेसिस बाय इमानुएल कांत. गैसियस हाइपोथेसिस बाय इमानुएल कांत, ब्रैकेट 1755, year 1755. In that, let's write down, this hypothesis is based on application of Newton's law of gravitation, application of Newton's law of gravitation and rotational motion Next point, according to him, originally there was, according to him, originally there was slowly rotating cloud of gas. There was slowly rotating cloud of gas and matter consisting of cold and motionless particles. Next point. The mutual gravitational attraction of particles. Mutual gravitational attraction of particles force them to start moving and colliding. Collisions led to friction and increase in temperature. It also caused rotational motion to the particles. Next point. At a particular point of time, the centrifugal force became more than centripetal force. Centrifugal force became more than centripetal force, and thus an irregular ring got separated from the central part of cloud of gas. Next point. The same process repeated The same process repeated 9 times to form 9 such rings. The same process but repeated 9 times to form 9 such rings. Next point. Through process of aggregation, of the matter of those rings, 9 planets were formed. In the same point, next line, the remaining matter of rings started rotating around planets. As their satellites. ठीक है. सो दिस वाज द फर्स्ट थ्योरी. सी आई फॉरगॉट टू टेल यू, जो भी हम डिक्टेशन पार्ट लिख के ले रहे हैं, बहुत ही अच्छे हैंड राइटिंग में टाइम लेके लिखिए. मैंने देखा है कि कुछ स्टूडेंट घर पे जाके अलग से नोट्स बनाते हैं जो यहाँ पे लिख रहे हैं उसका. डोंट वेस्ट योर टाइम इन डबलिंग योर एफर्ट्स. ठीक है, आपका ये नहीं होना चाहिए. सो ट्राई टू राइट इन अ गुड हैंड राइटिंग, ट्राई टू ड्रॉ द डायग्राम्स. सी दिस इज नॉट इम्पॉर्टेंट. मैं जब भी बोलूँगा ये डायग्राम ड्रॉ करनी है यहाँ पर, तो भी वो करना है. ये डायग्राम ड्रॉ करने की जरूरत नहीं है आपको. ठीक है, लेट्स राइट अबाउट सेकंड वन, नेबुलर हाइपोथेसिस. ओके, मैंने क्या लिखा है? ओके, started revolving around them as their satellites. Second one is nebular hypothesis by Laplace, 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 in bracket 1796. It is the modified version of gaseous hypothesis. Write down the first point. It is the modified version of gaseous hypothesis given by Kant. According to him, only one ring got separated from nebula in bracket cloud of gas. Nebula in bracket cloud of gas, bracket close. as against the 9 separate rings, as proposed by Kant. Read the statement again. समझ में आए? ठीक है. Write down next line. This one ring got later divided into 9 rings. This one ring later got divided into 9 rings. And the planets and satellites are formed. As explained in the gaseous hypothesis by Kant. ठीक है, सेम प्रोसेस में जो हमने ऊपर एक्सप्लेन किया. नाउ लेट्स राइट अबाउट थर्ड, प्लैनेटेसिमल हाइपोथेसिस. So I will explain this again. So some students were having doubts. ठीक है. So it is part of, we can say, binary theories, binary concept we can say, related to evolution of the earth. ठीक है. तो planetesimal hypothesis says that there were 2 celestial bodies. Okay, there was this proto-sun and this was companion star. Okay. According to Chamberlain and Moulton, this companion star was destined to move in a path that goes near or moves through, or we can say moves near the protosun. It was destined, मतलब इसके नसीब में था, ठीक है, कि वो इस तरीके से मूव होगा तो प्रोटोसन के नजदीक से जाएगा. Okay, they have assumed this. They try to understand this. They have assumed this to propose any hypothesis, any theory is proposed based on certain assumptions. है ना, आपने अब तक पढ़े होंगे सारे theories जो भी subject में, तो certain assumptions are there assumed by the proposer and then only it can be universally applied. ठीक है. So companion star, as it moved near to the protosun, it exerted huge amount of tidal force. Tidal force is basically the force of attraction, gravitational force of attraction. It is the gravitational force of attraction on this protosun, and because of this extreme level of tidal force, some matter from the surface of protosun got detached from it. बट इतना भी डिटैच नहीं हुआ कि ये इसको छोड़ दे. ठीक है. इट वॉज स्टिल अंडर द ग्रेविटेशनल इन्फ्लुएंस ऑफ प्रोटोसन. ओके. एंड नाउ द कंपेनियन स्टार मूव्ड अवे फ्रॉम द प्रोटोसन, तो उसका इन्फ्लुएंस कम हो गया एंड द डिटैच मास स्टार्टेड रिवॉल्विंग अराउंड द प्रोटोसन. ओके. पूरा ओके, ठीक है. सी द कंपेनियन स्टार एज इट मूव्ड नियर द प्रोटोसन, it exerted huge amount of tidal force and that led to extraction of some material particles from this surface of protosun. Okay, but that material that got extracted did not move with this companion star. Rather, it was still under the larger influence of this protosun. As the companion star moved away, this extracted material started moving around the protosun. Later on, again through the process of aggregation, it started coalescing each other, let's say with each other, and this is how the planets are formed. These planets which are still, we can say, revolving around the sun. ठीक है. The remaining part of the protosun is the present day sun. This is how they explain this formation of our solar system. Understood now? Let's write down about it. Planetesimal hypothesis. And yes, first draw this diagram. यहाँ पे ये diagram draw करिए. Mention here the protosun and the companion star. You can show the companion star with other color pen. Geography में आपको scope है, if time permits only, use the pencil or the color pen. Red pen छोड़ के सारा use करना है, क्योंकि इवेल्युएटर को भी चाहिए ना रेड पेन से वो लिखने वाला है. ठीक है. रेड पेन छोड़ के सारा यूज करिए. ठीक है. ओके. सो ड्रॉ दिस. फाइन. लेट्स राइट डाउन. Planetesimal hypothesis by Chamberlain and Moulton, bracket 1900, year 1900. It explained the origin of Earth and solar system with the help of two heavenly bodies, namely protosun and its companion star. protosun and its companion star. Next point. The companion star was destined to move. The companion star was destined to move near the protosun. Full stop. In the same point, next line. As the companion star came close to protosun, as the companion star came close to protosun, it exerted massive gravitational force. It exerted massive gravitational force on protostar. Massive gravitational force on protosun. Next point. Due to this, large number of small particles, got detached from the outer surface of protosun. These small particles were called planetesimals by Chamberlain. These small particles were called planetesimals by Chamberlain. Next point. The larger planetesimals became the nuclei for formation of future possible planets. Next point. Over the period of time, the remaining part of protosun became the present day sun. Next, now we'll write down about Big Bang theory. Big Bang theory. Okay, let's write down. It is also called as expanding universe hypothesis. Next, point. Edwin Hubble, EDWIN. Edwin Hubble, HUBBLE. In 1920, provided evidence that universe is expanding. This became basis for proposing Big Bang theory in 1950s. This became basis for proposing Big Bang theory in 1950s. In the same point, next line, it was validated through the evidences collected from COBE satellite, capital COBE, in bracket, Cosmic Background Explorer, COBE, Cosmic Background Explorer, in 1972. Okay, let's write down now a subheading within that. Explanation of how universe is developed. Explanation of how universe is developed through various stages. In that, let's write down according to the theory, all matter forming universe, according to the theory, all matter forming universe existed in one place in the form of a tiny ball, Next point, this tiny ball had unimaginably small volume, comma, infinite temperature and infinite density. Next point. Infinite density. Next point. At the event of Big Bang, in bracket, about 13.7 billion years ago, at the time of, or at the event of Big Bang, in bracket, about 13.7 billion years ago, bracket close, this tiny ball exploded violently. Which led to huge expansion. In the same point, next line, the rate of expansion was very high immediately after the event of Big Bang. The rate of expansion was very high immediately after the event of Big Bang. But later, it slowed down over the period of time. Next point. After Big Bang event, some energy got converted into matter. After Big Bang event, some energy got converted into matter. And within first 3 minutes of this event, the first atom began to form. Next point. Over the period of time, the temperature dropped significantly. Over the period of time, the temperature dropped significantly. And universe became transparent. Okay. Now next subheading we will give formation of stars and planets. As explained by Big Bang theory. Formation of stars and planets as explained by Big Bang theory. कैसे पता चला? See, this is just a proposal by the theory. ठीक है, जैसे टेम्परेचर ड्रॉप हुआ होगा, उस हिसाब से एनर्जी मैटर में कन्वर्ट हुई होगी. समझ में आ रहा है? मैटर जो है एनर्जी में कब कन्वर्ट होता है? वेरी हाई टेम्परेचर. ठीक है, एट वेरी हाई टेम्परेचर. एज द टेम्परेचर स्टार्टेड ड्रॉपिंग डाउन, सम एनर्जी गॉट कन्वर्टेड इनटू मैटर. ठीक है, तो जैसे टेम्परेचर कम होने का रेट इनको पता चला, तो उसके हिसाब से उन्होंने टाइम पकड़ा है कि इस टाइम पे हुआ होगा. ओके, यस. Now write down the first point in that. The uneven distribution of matter and energy. The uneven distribution of matter and energy in the early universe created density differences. Full stop. In the same point, this gave rise to differences in gravitational forces. This gave rise to differences in gravitational forces, and matter started getting drawn towards each other. And the matter started getting drawn or attracted towards each other. This formed the basis of formation of galaxies. This formed the basis of formation of galaxies. Next point. The galaxies formed by accumulation of galaxies were formed by accumulation of hydrogen gas accumulation of hydrogen gas in the form of very large cloud called nebula. In the form of very large cloud called nebula. In the same point, next line, eventually the growing nebula develop localized clumps of gases. Eventually, growing nebula develops localized clumps of gases. CLUMPS, clumps of gases. These localized clumps of gases later form the stars in galaxies. These localized clumps of gases later form the stars in galaxies. Next point, over the period of time, the gas cloud started getting condensed. Over the period of time, the gas cloud started getting condensed and the matter around the core developed into small rounded objects. Developed into small rounded objects, in bracket planetesimals, in bracket planetesimals, bracket close. Again I am repeating, the gas cloud started getting condensed and the matter around the core developed into small rounded objects, in bracket planetesimals, bracket close. Next point, later the large number of small planetesimals formed fewer larger bodies, fewer larger bodies called as planets, through process of accretion, ACCRETION, accretion. ठीक है, नेक्स्ट सब हेडिंग आर सोलर सिस्टम. In that, let's write down our solar system consists of sun, 8 planets, 63 moons, 63 moons, and millions of smaller bodies like asteroids and comets, and millions of smaller bodies like asteroids and comets, ASTEROIDS, asteroids and comets, COMETS. एनसीईआरटी में जो दिया है वही हम लिखेंगे। ठीक है, मैंने आपको एनसीईआरटी का डेटा लिखा है। ठीक है, वो नए मून्स तो मिलते रहते हैं उनके, ठीक है, अपडेट तो होता रहता है। ओके, हाँ ठीक है, इसका ही टोटल कर देंगे तो बहुत सारे हो जाएंगे। ओके, कट डाउन दैट फैक्ट। ठीक है, मून्स वाला हम अपडेट कर देंगे, लेटेस्ट मैं चेक करके आपको बताता हूँ। हाँ 63 मेंशन किया हुआ है, दैट्स व्हाई आई वाज टेलिंग यू। ठीक है, वो अपडेट करते हैं हम, लेटेस्ट वाला फैक्ट कोई नासा या किसी वेबसाइट पे मिलेगा तो। ठीक है, नेक्स्ट पॉइंट, एस्टेरॉइड्स आर rocks asteroids are rocks revolving around the sun, mainly between Mars and Jupiter, Next point, comets are irregular shaped landmass, having irregular path of revolution around the sun, ठीक है, हमें लगेगा कि कॉमेट जो है वो रिवॉल्व नहीं करता है, वो करता है, बट नॉट लाइक दीज प्लैनेटरी बॉडीज। ठीक है, जो इलिप्टिकल पाथ में ये रिवॉल्व कर रहे हैं ना, इंक्लूडिंग एस्टेरॉइड्स, बट द प्रॉब्लम विथ कॉमेट्स इज दैट इट इज नॉट रेगुलर शेप। ठीक है, रेगुलर शेप नहीं है उसका। ठीक है, ओके, नेक्स्ट पॉइंट, लेट्स राइट डाउन the planets between the asteroid belt and the sun are called inner planets. The planets between the asteroid belt and the sun are called inner planets, in bracket terrestrial planets, and those planets beyond asteroid belt, are called Jovian planets. Let's write the difference between these two. Just a moment. Okay, difference between terrestrial planets and Jovian planets. ठीक है, let's make a table. ठीक है, 2 columns. In first, write down terrestrial planets, and the second Jovian planets. Write down first point in terrestrial planets. these are four planets, namely Mercury, Venus, Earth and Mars. दूसरे कॉलम में लिखना है बाकी के चार: जुपिटर, सैटर्न, यूरेनस, नेपच्यून. In second point, terrestrial planets. These are called terrestrial because they are made up of. These are called terrestrial because they are made up of rocks and metals. Made up of rocks and metals and have relatively higher densities. अब दूसरे कॉलम में लिखना है these are called Jovian or Jupiter like. Jovian or Jupiter like. Jovian, Jovian or Jupiter like because they have thick atmosphere. They have thick atmosphere, mostly of helium and hydrogen. They have thick atmosphere, mostly made up of helium and hydrogen, similar to Jupiter. Similar to Jupiter. Next point in terrestrial planets. Terrestrial planets are very near to the sun. Where it was too warm for gases to condense. Where it was too warm, T-O-O, too warm for gases to condense to solid particles. Condense to the solid particles. In next Jovian, you will write, these planets were formed at a larger distance from the sun. Larger distance from the sun, and thus some part of gases are condensed into solid particles. And thus some part of gases is condensed into solid particles. Next, terrestrial में लिखेंगे next point. The strong solar winds near the sun. The strong solar winds near the sun blew off, BLEWOFF, blew off the gas and dust from terrestrial planets. The gas and dust from the terrestrial planets. In Jovian planet, we'll write down solar winds were not that intense to remove gases. Solar winds were not that intense to remove gases from Jovian planets. Next point, terrestrial planets. Next point, terrestrial planets. These are smaller and have low gravity. These are smaller and have low gravity comparatively. And therefore they could not hold the escaping gases. And therefore they could not hold the escaping gases. All right. And the next point, in the Jovian planet, these are large in size and have higher gravity. These are large in size and have higher gravity comparatively, and thus held on to the gases. Okay? Let's write down about evolution of the earth. Next subheading, evolution of the earth. Write down further subheading, evolution of lithosphere. Evolution of lithosphere. In that, write down, due to gradual increase in density, the temperature inside the earth increased. As a result, temperature inside the earth increased. Full stop. In the same point, as a result, the material inside the earth started getting separated. As a result, the material inside the earth started getting separated depending on their densities. Depending upon their densities. Full stop. Next point. The heavier material sank down towards the center of the earth. The heavier material sank down towards the center of the earth, and lighter one moved towards the surface. And the lighter one moved towards the surface. This process led to formation of different layers inside the earth. In bracket, crust, comma, mantle and the core. Crust, mantle and the core, bracket close. Then we'll write down evolution of atmosphere. Evolution of atmosphere. The present composition of atmosphere is different. Write down. The present composition of atmosphere is different than the primordial atmosphere. Primordial. Primordial atmosphere. The early atmosphere consisted gases like hydrogen, helium, methane. The early atmosphere consisted gases like hydrogen, helium, methane, which is different from present composition of atmosphere. Which is different from present composition of atmosphere, having gases like nitrogen, oxygen, CO2. Having gases like nitrogen, oxygen, CO2, carbon dioxide. Give subheading 3 stages in the evolution of present atmosphere. 3 stages in the evolution of present atmosphere. In that, first, impact of solar wind. Impact of solar wind. It is believed that the primordial atmosphere have been stripped off due to strong solar winds. Second step will write degassing. D-E-G-A-S-S-I-N-G. In that, write down, as the earth cooled down, the gases and water vapor were released from the interior. As the earth cooled down, the gases and the water vapor were released from the interior. This process is called as degassing. This process is called as degassing. The early atmosphere contained nitrogen, water vapor, carbon dioxide. Nitrogen, water vapor, carbon dioxide, methane, ammonia, but very little of free oxygen. Write down third stage. Modification of early atmosphere. Modification of early atmosphere. Write down. Continuous volcanic eruptions. Continuous volcanic eruption contributed water vapor and gases to the atmosphere. Water vapor and gases to the atmosphere. In the same point, next line, as the earth cooled down, the water vapor started getting condensed in the form of water. Water vapor started getting condensed in the form of water. In the same point, next line, CO2 from the atmosphere got dissolved in the rainwater. CO2 from the atmosphere got dissolved in the rainwater and temperature further decreased. फुल स्टॉप. यहां पे देखिए सब, क्यों टेम्परेचर कम हो गया है? Very good. So CO2 is basically greenhouse gas. More amount of greenhouse gas in the atmosphere means more amount of heat is trapped. We are going to learn about this in climatology part. Okay, how heat is trapped by greenhouse gases. And as the CO2 amount started decreasing, as it started dissolving in the rainwater, the overall temperature of atmosphere started decreasing. Okay, and then more and more condensation and further rain. ठीक है, तो इस तरीके से हाइड्रोलॉजिकल साइकिल जो है अभी तैयार होने लगा है. ठीक है, लेट्स राइट डाउन फर्दर. The rainwater falling on the surface got collected in the depressions to form oceans. The rainwater falling on the surface got collected in the depressions to form oceans. Can you imagine? Oceans नहीं होते तो वहां पे क्या था? Basically it was part of depression on the surface. तो over the period of time the water got collected in it, है ना? तभी तो oceans तैयार हुए. Write down further. Okay, around 2500 to 3000 million years ago. Around 2500 to 3000 million years ago, the process of photosynthesis got evolved. The process of photosynthesis got evolved. Oceans began to have oxygen, where marine life started evolving. Ultimately, the oxygen started flooding in the atmosphere. As the terrestrial life evolved. ठीक है, now you have understood the evolution of present atmosphere. Lastly, we'll write down evolution of biosphere. But there is one query. Sir, does degassing happens only via volcanic eruption? See, volcanic eruption is one of the method. In general, whatever, let's say, endogenic processes that are happening, there is heat inside the earth. There are, we can say, faults and gaps inside the earth. So automatically the gases are coming out of those gaps. अभी बताइए, गीजर्स और हॉट स्प्रिंग्स आपको पता है, ठीक है, शायद आपने कोई टूरिस्ट डेस्टिनेशन पे विजिट भी किया होगा. गीजर्स एंड हॉट स्प्रिंग्स. सो हॉट स्प्रिंग्स आर बेसिकली ब्रिंगिंग ऑल द गैसेस फ्रॉम इनसाइड, नो, गीजर्स एंड हॉट स्प्रिंग्स. ठीक है, तो अल्टीमेटली इट्स नॉट ओनली द वोल्केनिक इरप्शन. जहां जहां पे गैप्स है अर्थ क्रस्ट में, वहां से वो ऊपर आ रहा है गैस जो है वो. ठीक है. Evolution of biosphere. Lastly, we'll write a small paragraph. Initially, the Earth's surface and atmosphere was not conducive for development of life. Initially, the Earth's surface and atmosphere was not conducive for development of life. Scientists believe that origin of life happened. Scientists believe that origin of life happened due to certain kind of chemical reaction. Due to certain kind of chemical reaction, generating complex organic molecules, and assembling in a form of life, and generating complex organic molecules and assembling in a form of life. It has been assumed that life began to evolve somewhere around 3,800 million years ago. That life began to evolve somewhere around 3,800 million years ago. Biosphere is, write down, biosphere is intersection of, is the intersection of atmosphere, lithosphere and hydrosphere. Is an intersection of atmosphere, lithosphere and hydrosphere. It consists of flora, fauna and microorganisms. It consists of flora, fauna and microorganisms. ठीक है, so this was basically the dictation for complete session 1. Let's talk about now interior of the earth. ठीक है. So what we are going to learn in this session, interior of the earth, the second chapter of NCERT. पढ़ा है आपने? ठीक है. Okay. So again, those who have not read, you should read. It's very important. Why? जब मैं कुछ इंपॉर्टेंट बोलता हूं तो हमेशा मैं कुछ तो यूपीएससी को रिलेवेंस देता हूं। देखिए पहले ये देखते हैं, अगर वो सेकंड चैप्टर पढ़ोगे तो इसका आंसर मिल जाएगा इजीली। ठीक है, दिस वाज द एमसीक्यू, लेट्स रीड इट। और ये सेशन खत्म होने के बाद इसको आंसर करना है, अभी नहीं आंसर करना है। ठीक है, इन अ सिस्मोग्राफ P waves are recorded earlier than S waves. In P waves, the individual particles vibrate to and fro in the direction of wave propagation, whereas S waves, the particles vibrate up and down at right angles to the direction of wave propagation. So P and S waves are basically earthquake waves, seismic waves. We are going to learn about their properties and how these seismic waves help us to understand the interior of the earth, the structure and composition of interior of the earth. This is what the complete chapter is all about. Okay, so this one, some mains questions also. अभी तक नहीं पूछा गया है, ये पेंडिंग क्वेश्चंस है यूपीएससी में. सो tomorrow next time there can be a question on the basis of this topic. What do you understand by shadow zone? How does it help to understand Earth's interior? Explain the role of seismic studies in understanding structure and composition of Earth's interior. Then what are the earthquake waves? Differentiate between P waves and S waves. If they can ask question in prelims, they can ask question in mains also. ठीक है, so at the end of this session we should be able to write the answers to these questions and able to attend the UPSC question successfully. ठीक है, so what we are going to learn, the agenda here is okay, first of all let's have a look at sources of information of interior of the earth. There are some direct sources, there are some indirect sources. We'll try to understand them. Thereafter we'll look into details of seismic studies, the earthquake waves, and how the shadow zones are formed for P waves and S waves, how it helps us to understand role of shadow zone in understanding structure of the earth. Thereafter we'll try to also get more detailed information about the structure of interior of the earth, structure and composition, and then discontinuities that are there inside the earth. ठीक है, let's first talk about the sources of information. लिख के अलग से लेंगे हम डिक्टेशन में. ठीक है, let's try to understand first. Now before studying the interior of the earth, let's first understand why we should study interior of the earth. क्या जरूरत है सर अंदर का जानने की? चांद तक पहुंच गए हम, बाहर का ही ठीक है, अंदर बहुत गर्मी है ना? इट्स वेरी हॉट इनसाइड. हाउ डू वी अंडरस्टैंड? कैसे जाना अंदर? नहीं होगा, मुश्किल है. बट व्हाई वी शुड लर्न अबाउट अर्थ्स इंटीरियर? ठीक है, कंपोजिशन. बट व्हाई कंपोजिशन? ओके, फर्स्ट इज लेट्स मिनरल्स. ठीक है, आपको लग रहा है कि मिनरल्स ठीक है, आर्ग्यूमेंट इज वैलिड, बट मेजर आर्ग्यूमेंट्स. हाँ, ये बात करो. ठीक है, सम ऑफ द प्रोसेसेस दैट आर ओरिजिनेटिंग फ्रॉम इनसाइड द अर्थ resulting into some natural hazards, they are impacting us. Best example, earthquake, volcanism, tsunami. कहां से आ रहा है? अंदर से फोर्स आ रहा है ना, उसकी वजह से ये सब हिल रहा है. हुआ था कुछ दिन पहले दिल्ली में, है ना? हम ऐसे ही लंच करके बैठे थे, टेबल हिल रहा है, सब नीचे चले गए, सब एकदम डर के. ठीक है, so basically where it is originating inside. So if we understand what is happening inside the earth, we'll get more idea about it. Then magnetic field, very important. To understand how this magnetic field works, origin, तो उसके लिए हमें इंटीरियर कंपोजिशन पता होना चाहिए, ठीक है. देन फर्दर ग्रेविटेशनल फील्ड, ठीक है. देन फर्दर यस, see all this distribution of continents and oceans that we see on the surface today, all these mountains and all these landforms are formed. They are formed because of some endogenic forces, processes, like volcanic eruption, or these mountains, Rockies, Andes, how the Himalayas are formed. तो इसका origin जो है inside the earth है. Something is brewing up inside the earth. कुछ तो churning हो रहा है, ठीक है. तो उसकी वजह से ये सब उसका impact दिख रहा है हमें. तो out of curiosity also we should be knowing about how these are formed, ठीक है. तो ये सारे reasons है, and that's why we should know about inside the earth. But as I told you, it's very hot inside the earth. How do we get information about the interior? ये एक challenge था हमारे पास. Initially we had some direct sources, direct in terms of whatever we observe, whatever the material that is studied, that is coming from inside the earth, that is studied directly, हम उसको direct sources बोलते हैं, ठीक है. And the indirect sources is simply studying the indirect impact of whatever happening inside the earth, ठीक है. तो उसको indirect बोला गया है. So which are these direct sources? Let's see one by one. First, study of surface rocks. So geologists or geographers, they study the surface rocks, and from that they come to understand that the earth's crust is made up of these rocks, or may have been formed or composed of these rocks. Study of surface rocks, ठीक है. So let's take example of Deccan Plateau. So there we find the basaltic rocks, or we can take example of some areas having active volcanoes, तो वहां पे volcanic rocks मिलेंगे, ठीक है. So that means different kinds of rocks can be found in different areas. They are studied, and from that we get some information about the interior of the earth. But it is not sufficient, ठीक है. It is not sufficient. Then rocks derived from mines. Okay, so mines थोड़ा सा deeper dig किया हुआ रहता है. So of course we are getting a little bit inside the earth to understand what is there. And we have found different kinds of rocks there. जो surface में मिल रहे थे वो थोड़े से अलग थे. So we studied them, but still it was insufficient to understand the complete, let's say, interior and its composition. Then there were some drilling projects undertaken by different countries. Like for example, Russia, USSR at that time, in Kola Peninsula, the northern part of Russia, we can say attached to Arctic Sea, ठीक है. There the deep sea drilling project was undertaken, which reached up to 12 kilometers at present. Gold mines of South Africa, 3 to 4 kilometers deep inside. You can imagine 3 to 4 kilometers inside. हम walk नहीं करते उतना, इतना दूर होता है वो डेली, ठीक है. तो इनसाइड द अर्थ यू कैन इमेजिन, ओके. हम 4-5 किलोमीटर ऊपर भी चले जाए ना एटमॉस्फेयर में तो आधी दुनिया दिखेगी, ठीक है. इनसाइड द अर्थ. सो 12 kilometers. Now it is drilling project. So whatever the material that is extracted, now that is studied there, ठीक है. So again, but it is up to 12 kilometers only. So what is further? They are inside the earth, beyond 12 kilometers. Again, we have to understand that. And it was difficult to understand. One more important direct source was volcanic eruption. Our different places on the earth's surface are having volcanic eruption. And this is bringing the material from inside the earth to the surface. This magma that is coming up from volcanic eruption, that is helping us to understand अंदर क्या हो सकता है, जो ये ऊपर आ रहा है इसका composition क्या हो सकता है. But still the geographers or geologists feel that ये तो कहीं तो भी नीचे यहीं पे है, वहीं से ऊपर आ रहा है, उसके अंदर भी और कुछ होगा. Okay, and that's why the direct sources are providing limited information. They are providing limited information, not holistic picture about the interior of the earth. Some indirect sources are also studied, and some of them, like for example meteors, it's not that much dependable, but it is understood that the way universe is formed, in the same manner the other celestial bodies are also formed and earth is formed. So whatever the meteors that are coming inside the earth's atmosphere and some of them are falling on the earth's surface, they are studied. It is believed that whatever the earth's interior is made up of, तो ये भी उसी तरीके से तैयार हुआ है, उसका कंपोजिशन भी सेम होगा. meteors, ठीक है. What are meteors? Simply the rocks that are wandering in the space. They are wandering in the space. They are, let's say, their trajectory, that can come across like Earth's atmosphere. They enter into Earth's atmosphere, but the Earth's atmosphere is dense. It is dense, and when these rocks enter into the Earth's atmosphere, there is huge friction, and that's why they start burning. This is how meteor shower is seen at night time. Yes, there is a difference. Comets have a predetermined path. ठीक है, उनका path है fix around the sun. It is irregular, but they are passing in a predetermined, उनका fixed path है. Meteors are wandering rocks. There is difference in size also. Comparatively, comets are larger in size. But ये जो meteors होते हैं, these are, we can say, इतना बड़ा एक rock ही होगा complete. ठीक है. अब वो आते आते जो है पूरा burn out हो जाता है. Maximum meteors are burned out and very few are reaching to the earth's surface. And if larger one is reaching on the earth's surface, that can have huge impact. That can create depression. Like present day, Lonar Lake in Maharashtra is formed due to meteor impact. Lonar Lake in Maharashtra, those from Maharashtra, they must be knowing. ठीक है, तो meteor impact. ठीक है. Now, temperature, pressure and density properties of matter. As we learn in the evolution of lithosphere, what happened is there was density differentiation, and the denser material got deep inside the earth and less denser came up. ये जब studies की गई तो उससे पता चला हमें composition के बारे में. Okay, then temperature and pressure, I told you the pressure goes on increasing, temperature goes on increasing. Why? Pressure is because of overlying rocks. Okay, and when there is increasing pressure, temperature increases. Temperature increases. So remember, these properties help us to understand the way these properties are changing from surface to the interior. ठीक है. Then gravitation. Yes, of course, we know that the value of small g at poles is a little bit higher as compared to the value of g at equator. Why? Yes, yes. So that means our Earth's surface is a little bit flatter near the, इस तरीके से, इतना भी नहीं, इस तरीके से, यहाँ पे फ्लैट है, ये थोड़ा बल्ज है इक्वेटर पे. So this distance is comparatively higher than this distance, and that's why g, value of g, इनवर्सली प्रोपोर्शनल टू द रेडियस, नो, ठीक है। तो जहां कम होगी रेडियस तो वो फिजिक्स में पढ़ा था, है ना, मुझे भी याद आता है, ठीक है। तो ये डिस्टेंस ज्यादा है तो यहाँ वैल्यू ऑफ जी कम हो जाता है। दिस हैज हेल्प अस टू अंडरस्टैंड द कंपोजिशन, ठीक है। या फिर ये समझ में आया कि यहाँ पे जो है फ्लैटर है और यहाँ पे बल्ज है, ठीक है। along with that the distribution of matter inside the earth help us to understand the different values of g at different locations on the earth surface, ठीक है। distribution of matter, then magnetic field, there is something called as magnetic anomalies, okay, and the magnetic surveys of magnetic materials around the world has helped us to understand these anomalies. That means the study of rocks, when these rocks are formed, ठीक है, volcanic eruption होता है, फिर उसके बाद वो magma solidify होता है. When this magma is getting solidified, the magnetic material inside the rock is also getting solidified. समझो rock है, rock is having different minerals, rock is having different minerals and metals, तो उसमें iron भी तो होगा, ठीक है, और other magnetic materials like nickel. So what happens to that material when it is getting solidified? It gets aligned to that time period's Earth's magnetic field. It gets aligned, मतलब क्या है कि अर्थ का मैग्नेटिक फील्ड जो है आज के टाइम पे नॉर्थ साउथ पोल्स जो है, मैग्नेटिक नॉर्थ एंड मैग्नेटिक साउथ, दिस हैज बीन डिफरेंट इन द पास्ट. देयर हैज बीन मैग्नेटिक रिवर्सल चेंजेस इन द पास्ट. तो अभी का जो नॉर्थ पोल है ना मैग्नेटिक, वो कभी साउथ भी था, और जो साउथ था वो कभी नॉर्थ था. मैग्नेटिक पोल्स आई एम टॉकिंग, नॉट ज्योग्राफिकल पोल्स. The understanding of these magnetic anomalies has helped us to understand that magnetic poles had changed in the past. तो ये अर्थ के इंटीरियर में कुछ चेंजेस हो रहा है, तब जाके तो ये मैग्नेटिक फील्ड चेंज हो रही है. That's why it is changing, right? We have understood that from understanding magnetic field, or we can say that magnetic anomalies that are there from these rocks. To know about the Earth's composition and what particle is made of. ठीक है, वो old वाला comment है. Fine. Ultimately, our last one and the most important, the most reliable source to understand the interior of the Earth is, okay, first of all, why reliable? Let's try to understand this. Seismic study. Seismic means something related to earthquake. Seismic means something related to earthquake or study of earthquakes. Study of earthquakes. Now, in this seismic activity, we are studying how the earthquake is happening, how there is a release of energy inside the earth, which is traveling in the form of waves, primary waves, secondary waves, and surface waves. And after studying those waves, we come to understand that these waves and their properties, they are behaving in a very different manner inside the earth. From that we understood कि ये जिस मीडियम से पास हो रहा है, the medium through which they are passing, it is of having different densities. That's why the properties of these waves are changing. That's why the properties of these waves are changing. We are going to learn about this in detail. So, as these waves are also passing through mantle as well as core, that means it is reaching and passing through core, center of the earth, and then coming on the surface of the earth. The understanding of their properties will help us understand the structure and composition. हम जहां नहीं पहुंच पा रहे वहां पे ये वेव्स जा रहे. और फिर वो वापस भी सरफेस पे आ रहे हैं. दैट्स व्हाई इट इज मोर रिलायबल. इट इज मोर रिलायबल. फाइन. चलो आपको अभी सोर्सेस पता चले. सोर्सेस यूपीसी विल नॉट आस्क दिस, ना प्री में ना मेंस. ठीक है कि विच ऑफ द फॉलोइंग आर डायरेक्ट सोर्सेस ऑफ वी कैन से इंफॉर्मेशन ऑफ इंटीरियर ऑफ द अर्थ. अब 20 साल पहले ऐसा आता होगा, अब नहीं आता है क्वेश्चन. ठीक है. सो जस्ट फॉर योर अंडरस्टैंडिंग यू शुड रिमेंबर. लेट्स अंडरस्टैंड द कॉन्सेप्ट ऑफ अर्थक्वेक. ओके. सो earthquake is in simple term it is shaking of earth surface. It is shaking of earth surface. GS में यही definition है. जनरल स्टडीज के अपना ज्योग्राफी सब्जेक्ट है, इसमें यही डेफिनेशन लिखना है. शेकिंग ऑफ अर्थ सरफेस. हाउ इट इज हैपनिंग, लेट्स अंडरस्टैंड द फिनोमेनॉन. We know that earth is made up of rocks of different sizes. ठीक है. एक छोटा हो सकता है, एक इतना बड़ा भी हो सकता है, इससे भी बड़ा हो सकता है. The earth is made up of rocks of different sizes and these rocks are, we can say, assembled together. They are assembled together and they are at present in certain state of equilibrium. Certain state of equilibrium मतलब क्या है? ठीक है. Suppose these are two rocks, okay, and these rocks are also attached with other rocks, surrounding rocks, but in a state of equilibrium, let's say these are now like this. Okay, these are like this. Let's say because of any other external factor, ठीक है, कहीं तो भी दूर क्या हो रहा है, कोई एक चेंजेस हो रहा है रॉक्स में. अब उसकी वजह से क्या है, ये जो अटैच्ड वाला रॉक्स है इस पे प्रेशर आ गया एंड नाउ इट स्टार्ट मूविंग अलोंग द फॉल्ट प्लेन. फॉल्ट प्लेन मतलब क्या है, इसका जो इंटरफेस है ना, दोनों का जो प्लेन है इंटरफेस, उसको फॉल्ट प्लेन बोला गया. Now when this moves along this plane because of some external factor जो इसको ही इफेक्ट कर रहा है, now this is moving like this, let's say, because of this what happens is some energy is released along this fault plane in form of friction. Now you must be saying कि सर पहले क्यों नहीं हुआ? Earlier it was staying like this because the frictional force was more as compared to the other forces, so it was holding on in this state. जब ये फोर्स ओवरकम करेगा तो ये स्लाइड कर देगा. when this overcome the frictional force, slide कर देगा. And because of that there is release of energy at that point. Let's say this is one rock, this is another rock, and this is fault plane. Imagine this is fault plane. Let's say what happens is, due to some other factors, this rock is now subsiding down, moving down along this fault plane. What will happen? There will be release of energy along this plane at some point along this plane. At some point along this plane. That point is called as focus or hypocenter. That point is called as focus or hypocenter. Remember this, very important. ये पूछा जा सकता है prelims में. Okay, hypocenter. And what happens is, this energy is now spreading in all direction from this point. Spreading in all direction from this point in the form of waves. In the form of waves. And these waves are called as earthquake waves. I am telling you waves. That means there are different kinds of waves. There are different types of waves. We are going to understand that. Getting the phenomenon. कैसे होता है earthquake? Again I am repeating. Earth's crust or interior is made up of rocks. And these rocks are basically trying to settle with each other. ठीक है? They are trying to settle with each other. But due to external factors, if one rock is changing its position along the fault plane due to some external force, what happens is there is release of energy along the fault plane at certain point along the fault plane, and that point is called as focus. This energy is spreading all around in the form of earthquake waves, and we can say studying those properties of those waves help us understand what is there inside the earth. Now pay attention here. This was focus. Now the first point on the earth's surface where the first earthquake wave generated from focus will reach on the earth's surface, that point is called as epicenter. Again I am repeating, the point on the earth's surface where the first earthquake wave is reaching, it is called as epicenter. Generally it is exactly above the focus. Generally it is exactly above the focus on the earth's surface. So let's say try to imagine earth है, यहाँ पे earth crust में कहीं तो भी यहाँ पे earthquake हुआ है, that is the focus. Now the waves will travel in all direction. These waves will travel in all direction, और जो exactly above है वो भी, तो नजदीक में ये है ना, सबसे पहले यहाँ पे आएगा, and that is epicenter. So that means the seismograph, which is the instrument to record the earthquake waves, seismograph, which is the instrument to record the earthquake waves, receives the first wave at epicenter. First wave at epicenter. ठीक है? Understand this? सबको समझ में आ रहा है ना क्या चल रहा है? नहीं समझ में आ रहा तो बताना. ठीक है? Now after this let's understand the types of earthquake waves. Basically the earthquake waves can be divided as body waves and surface waves. Body waves and surface waves. Okay? Now when I say body waves, simply it is passing through the body of the earth. It is passing through body of the earth, or generated within the earth and passing through the earth. But the surface waves are basically generated on the surface due to interaction of body waves with the surface rocks. Again I am repeating, body waves are those earthquake waves which are generated within the earth and traveling within the earth, later on reaching the earth's surface. But surface waves are those waves which are generated on the surface of the earth due to interaction of body waves with the surface rocks. That's why the name surface waves. ये different है दोनों. बॉडी वेव्स यहाँ पे ओरिजिन हो रहा है, सरफेस वेव्स सरफेस पे अलग से ओरिजिनेट हो रहा है. ठीक है? Body waves are basically those waves which are generated within the earth's surface and then they are traveling in all direction. Thereafter they are reaching to the surface. When they reach the surface, they interact with surface rocks. ठीक है? They interact with surface rock. समझो ये प्लेटफॉर्म है, ये surface rock है. For example, this is a surface rock, and let's say the body wave is coming from inside and touching this rock. It is transferring some energy to this rock. It starts to vibrate. Basically, it generates a separate kind of waves. The surface rock, that is called as surface waves, which are the most destructive. They are most destructive than the body waves also. तो जब बड़ा अर्थक्वेक आता है और जब हम ये डिस्ट्रक्शन देखते हैं तो largely it is caused by these surface waves. We'll try to understand that separately. Now understood? Okay. Now within body waves there are two types of waves, P waves and S waves. Within body waves there are two types of waves, P waves and S waves. Now how the seismograph receives these waves? The seismograph receives these waves in sequence of first primary waves, second, and in the end it receives. And how does it look like? Seismograph कैसे दिखता है? P waves, S waves, surface waves. Huge amplitude change, surface waves. Third one to arrive on the seismograph. ठीक है ना, एक ऐसा नीडल होता है ना, वो पेपर पे ऐसा 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 करता है, सीस्मोग्राफ जो होता है, ठीक है. सो P waves, S waves and surface waves. This is how in sequence they arrive, and from that we understand what is the focus of the earth, focus of the earthquake. Thereafter the, let's say, early warning is, we can say, released. ये सारी चीजें जो है इसी इंफॉर्मेशन से मिलती है. फर्क इनके नेचर में नहीं है, फर्क उनके प्रॉपर्टीज में है. दैट वी विल अंडरस्टैंड. ठीक है, उनके प्रॉपर्टीज में है. वो दिखता ऐसा ही है सीस्मोग्राफ पे, और ये बड़ा दिखता है ऐसे, बट प्रॉपर्टीज में डिफरेंस है. लेट्स अंडरस्टैंड दैट. आफ्टर अंडरस्टैंडिंग दिस प्रॉपर्टीज ओनली वी गॉट टू नो हाउ different layers are there inside the earth. ठीक है, let's talk about now these properties in a comparative manner. कंपेयर करके ही पढ़ना है ताकि याद रहेगा. हाँ बोलो. सरफेस वेव पहले आएगा. नहीं नहीं, देखो क्या होता है ना, पहले जब आ रहा है नीचे से तो प्राइमरी वेव आता है, तो रिकॉर्ड हो गया. उसके बाद जो प्राइमरी वेव है उस सरफेस रॉक्स के साथ इंटरेक्ट करेगा, उसके बाद वो सेकेंडरी वेव जनरेट होगी, उसके बाद वो रिकॉर्ड होगी. गेटिंग दिस? फर्स्ट लेट देम जनरेट. और वो कैसे होंगे? पी वेव्स ऊपर आके इंटरेक्ट करके होंगे, है ना. तो हाँ, प्राइमरी वेव, सेकेंडरी वेव्स एंड देन सरफेस वेव्स. ठीक है. नाउ व्हाई दे आर कॉल्ड एज पी वेव्स? सिंपल शॉर्ट फॉर्म फॉर प्राइमरी वेव्स. एस वेव्स, सेकेंडरी वेव्स. नाउ व्हाई दे आर कॉल्ड एज प्राइमरी वेव्स? फर्स्ट वन टू अराइव. व्हाई दे आर कमिंग फर्स्ट? बिकॉज दे आर faster as compared to secondary waves. They are comparatively faster. See, second one to arrive, comparatively less speed or velocity. ठीक है, तो ये डिफरेंस है, फर्स्ट डिफरेंस. सेकेंड इंपॉर्टेंट डिफरेंस, ये प्राइमरी और सेकेंडरी तो है, बट इसके नाम देखिए. सेकेंडरी वेव्स आर ऑल्सो कॉल्ड एज ट्रांसवर्स वेव्स, shear वेव्स, डिस्टॉर्शनल वेव्स. ये ठीक से पढ़ना है, वो एमसीक्यू का आंसर देना है आपको इसके बाद. यूपीसी वाला जो है, नॉट यूपीसी वाला. ठीक है, ठीक है. नाउ रिमेंबर दिस, प्राइमरी वेव्स आर आल्सो कॉल्ड एज लॉन्जिट्यूडनल वेव्स. जैसे ये ट्रांसवर्स वेव्स है, राइट. सो लॉन्जिट्यूडनल वेव्स. Now what is the example of longitudinal wave? 10वीं तक हमने पढ़ा है साइंस में. हाँ बताओ. साउंड वेव्स. Of course, longitudinal waves, example, sound waves, the best example. Now, what happens in sound waves? How they travel? How they travel? इस तरीके से ट्रैवल करते हैं क्या? Compression, rarefaction, compression, rarefaction. This is how they move, sound waves or longitudinal waves. So that means they are vibrating to and fro along the direction of movement of waves. Again I am repeating, they are vibrating to and fro in the direction of movement of waves. In the direction of movement of waves. These are longitudinal waves. तो मुझे बताइए, जो मटेरियल है जिसके थ्रू ये पास कर रहे हैं, या मीडियम जो है उसके थ्रू ये पास कर रहे हैं, what will happen to that matter? It will also expand and contract, expand and contract. And because of that, there will be stretching and squeezing of the material. Because of that, it will cause stretching and squeezing of the material. Understood? समझ में आया नहीं है? Now, about these waves. These are similar to transverse waves. The best example of transverse waves is the way ripples are formed on the water surface. बचपन में हमने लेक में ऐसे पत्थर फेंका होगा. Whatever the waves that are formed, basically these wave trains are the transverse waves. Other example is light wave. Light transverse waves है, ठीक है. How they travel? Light wave. How they travel? Forming crest and trough. They form crest and trough. That means they are moving up and down. Up and down. So here the movement of the particles through which they are let's say wave is passing, this movement is perpendicular to the direction of. कैसे हो रहा है ये यहाँ पे कैसा हो रहा था? In the direction of movement of wave, perpendicular to the direction of movement of wave. यही तो पूछा है वो क्वेश्चन में, ठीक है. Now because of this, what will happen to the matter or the medium through which it is passing? It will create troughs and crust in the material, or it will distort the material. That's why the name distortional waves. क्या करेगा ये? डिस्टॉर्ट करेगा. नहीं समझे? एक कोई रॉक है और उसमें से सेकेंडरी वेव जा रहा है, तो या ऐसे ऐसे करेगा, ठीक है. ऐसे ऐसे नहीं, ऐसे ऐसे करे तो डिस्टॉर्ट कर देगा वो मटेरियल को. ओके, सो दैट्स व्हाई द नेम डिस्टॉर्शनल वेव्स. नाउ साउंड वेव्स. व्हाट इज द प्रॉपर्टी ऑफ साउंड वेव्स? Which mediums, in which mediums it passes? It passes through all mediums, solid, liquid, gases. सर पानी में आवाज थोड़ी आता है. अरे हमें नहीं सुनाई देता होगा, बाकी एनिमल्स को तो देता है ना, राइट? So simply you understand that the sound waves or longitudinal waves, they can travel through or pass through all three mediums. Sound जो है वो liquid, solid और rather we can say that the speed of sound is much faster in solid, then less in liquid, and then less in air. Why? Of course, physics अच्छा था, ठीक है. So due to compactness of molecules of that matter, ठीक है. So here velocity decreases, solid, liquid and gases. I told you vibrate parallel to the direction of waves, and we can say comparatively least destructive. Comparatively least destructive. The highest destructive capacity is of surface waves. Second highest is by secondary waves, S waves, and least primary waves. Destructive capacities. Okay, here transverse waves, they do not pass through fluids. Fluids means liquid as well as gases. Fluids means liquids as well as gases. That means they can pass through only solids. Now this unique property is helping us understand कि जो composition है, whether the particular part of interior of the earth is in liquid state or solid state, that has helped us to understand that outer core is in liquid state and inner core is in solid state. We'll see that in shadow zones. ठीक है, जब हम shadow zones के बारे में बात करेंगे ये waves के, तब हमें वहां पे समझ. Is it clear now? चलिए वो सॉल्व करते हैं. इस साल का एमसीक्यू है. अगर ये सॉल्व होता है तो मतलब हम सही तरीके से पढ़ रहे हैं. ये पहले से ही सॉल्व हो गया था. अगेन आई एम रीडिंग द स्टेटमेंट. अब बताइए आंसर क्या होना चाहिए इसमें. हाँ, ऑनलाइन स्टूडेंट्स गिव योर आंसर्स क्विकली. Okay, both 1 and 2. Everyone? Okay, Amit. Yes, Chirag. Good. In seismograph, P waves are recorded earlier than S waves. Okay, P waves, S waves, surface waves. Is it clear now? Then in P waves, the individual particles vibrate to and fro in the direction of propagation of that wave. That is true, longitudinal waves. And S waves, particle vibrate up and down perpendicular to the direction. Very easy. सर ने बहुत अच्छे से एक्सप्लेन किया है अभी. अब नहीं भूलेंगे. मैंने क्यों कंपैरेटिव बोला? यूपीएससी ने देखो कैसे क्वेश्चन पूछा है, एक ही स्टेटमेंट में कंपेयर करके पूछा है ना, इसलिए इंपॉर्टेंट है. अब ये मेंस का देखो क्वेश्चन, इसका आंसर कल लिख के लाओ. फिर लिख लो, ये क्वेश्चन लिख लो. चलो ये सेकंड क्वेश्चन रहने दो, फर्स्ट और थर्ड का आंसर लिख के लाओ. सॉरी, थर्ड का आंसर लिख के लाओ. व्हाट आर द अर्थक्वेक वेव्स? डिफरेंशिएट बिटवीन पी वेव्स एंड एस वेव्स. रीड द एनसीईआरटी चैप्टर, thereafter write answer to this. ठीक है. ओके, any doubt, any question till the point? Difference. Meteorites, right? So what is the difference? Asteroids are called as asteroids till the time it is not entering into Earth's atmosphere. ठीक है, तो उसको एस्टेरॉइड बोल सकते हैं आप, बट जब वो एंटर करेगा अर्थ एटमॉस्फेयर में तो वो हम उसको मेटेरॉइड बोलेंगे. वन डिफरेंस. सेकेंड डिफरेंस इज एस्टेरॉइड्स आर बेसिकली रिस्ट्रिक्टेड टू द बेल्ट दैट इज बिटवीन मार्स एंड लार्जली. मेटियोर्स पूरे स्पेस में किधर भी घूम रहा है, वॉन्डर कर रहा है. एस्टेरॉइड्स लार्जली दे आर रिवॉल्विंग अराउंड द सन इन अ पर्टिकुलर बेल्ट. ठीक है, तो ये मेन डिफरेंस. अंडरस्टूड? Seismograph. See, it is both amplitude, and from amplitude we understand intensity also. We'll talk about that, how the earthquake is measured, Richter scale and Mercalli scale. ठीक है, उसके बारे में हम अगले सेशन में पढ़ेंगे. ठीक है. It is also part of natural hazards, earthquake जो है. नहीं समझा? डिफरेंस नहीं समझा? See, when the energy is released in the earth's crust at a particular point, that point is called as hypocenter or focus. अगर कंफ्यूजन हो रहा है तो फोकस याद रखिए. मैं इसकी ट्रिक बताता हूँ याद रखने के लिए. ईपी सेंटर बोल रहा है ना, ईपी सेंटर मतलब ऊपर वाला याद रखिए, ऊपर. ईपी ऊपर इस तरीके से, तो हर सरफेस पे जो आ रहा है तो वो आपका ईपी सेंटर होगा. ठीक है. एंड द पॉइंट वेयर द एनर्जी इज रिलीज्ड, इट इज फोकस. इट इज द फोकस. वहां से सारा वेव्स जो है अलग अलग डायरेक्शन में जा रहा है. राइट. सो दैट इज द फोकस. रिमेंबर, इट इज द ओरिजिन ऑफ ऑल द वेव्स. ठीक है. पी वेव्स और एस वेव्स बॉडी वेव्स का ओरिजिन है यहां से. एंड देयर आफ्टर वी कैन से सरफेस वेव्स आर फॉर्म एट द सरफेस. ठीक है. एनी अदर क्वेश्चन ऑनलाइन स्टूडेंट्स? हो या खाना खा रहे हो? हाँ, ऑनलाइन स्टूडेंट्स यू कैन सबमिट योर आंसर्स हियर इटसेल्फ. आपकी फाइल जो है आप यहाँ पे डालिए, मैं पढ़ के आपको बता दूंगा रिव्यू. ठीक है. कल के सेशन में आप वहां पे अपलोड कर दीजिए आपकी फाइल. हो जाती है ना, है ना? हाँ, तो वो अपलोड कर देना वहां पे. ओके फाइन, देन लेट अस स्टॉप फॉर टुडे. बाकी का सेशन कल. ठीक है. शुरू में थोड़ा एक्सटेंड होगा, स्लो स्पेस पे चल रहा है. जस्ट यू नो टू मेक यू फैमिलियर विथ ज्योग्राफी. फास्ट ले सकता हूं मैं, बट द थिंग इज कि शुरू में क्या होगा, आपको समझने में टाइम लगेगा. कुछ स्टूडेंट्स ने एनसीईआरटी पहले से पढ़ा होगा, एंड सम स्टूडेंट्स माइट हैव ऑलरेडी डन सम ऑनलाइन कोचिंग फ्रॉम काइंड ऑफ, मैंने जो क्लास का नाम लिया था ऐसे ही थोड़ा सा कम पैसे में हो जाता है, बट पूरा अंडरस्टैंडिंग नहीं होता है. राइट. सो दैट्स वाई वैरायटी ऑफ स्टूडेंट्स. तो दैट्स वाई इनिशियली हम पेस थोड़ा सा स्लो रखेंगे, बट स्लोली स्लोली, स्पेशली ह्यूमन और इकोनॉमिक ज्योग्राफी में आपको समझने वाली चीजें कम है और याद रखने वाली चीजें ज्यादा है, तो वहां पे फास्ट चलेगा. डिक्टेशन भी फास्ट चलेगा, सारा इंफॉर्मेशन ही है ना. सो आई विल बी लाइक शोइंग अ मैप, उस पर मैं डिलीनेट करूंगा, वो हो गया एक रिसोर्स, उसके बाद अगला रिसोर्स, इसी तरह से चलेगा वो. ठीक है. तो आपको साथ साथ में उसके नोट्स बनाने हैं. ठीक है. सो इट विल नॉट टेक दैट मच टाइम. फाइन. एक दो सेशंस आपको ज़्यादा भी लगेंगे, हमें 40 का 41 42 भी हुआ, तो दैट इज़ फाइन. ठीक है.